So I'm going to show you first of all how to find the value of k, where f of t is a probability density function for a continuous random variable. The function is k times t cubed and exists between 0 and 2. So we need to use the fact then that the integral of f of t between 2 and 0 will come to 1. That's the definition of a probability density function. So the integral of kt cubed then is going to be k times t to the power 4 all over 4 between 2 and 0. Now 0 will give us nothing at all, so what we're going to get here is t to the power 2 times t to the 4, so substitute the 2 in for the t, so 2 to the power 4 is 16 over 4, so that's going to give me 4k, so that gives me 4k, and of course that must be set equal to 1, so therefore k equals 1/4, so that gives me then my function of t equals t cubed over 4, between values of t between 0 and 2. So I'm now required to find the expected value of t, and we should remember that the formula will be t times the function of t, so I'll write that in so you can see exactly where that's come from. Alright, that's given to us, that's the formula. So t times the function of t will be the integral, I should put the limits of 2 and 0, and it'll be the integral of t times t cubed over 4 t to the power 4 all over 4 with respect to t. So integrating that then, we're going to have t to the power 5, and then the 5 comes down on the bottom and multiplies the 4, giving me 20 between 2 and 0. Now the 0 won't give us anything at all, so that makes it fairly easy. T to the power 5 is 32, so we've got 32 over 20. 32 over 20, which is 1.6. So we have a mean value of 1.6. So remember that e of t equals 1.6. So we're trying to find the variance of t now. The variance of t formula is e of t squared minus e of t all squared. So we can drop in out 1.6. So really all we need to do here is to find e of t squared. So remind you, the formula for e of t squared will be the integral between the limits applied to the particular problem. We know that's 2 and 0, but then in general it's t squared or x squared, whatever you're using, times function of that value, so function of t dt. So we now substitute in f of t and multiply by t squared. So you'll see I've dropped that in, so the integral between 2 and 0 of t squared times t cubed over 4, which is going to equal the integral between 2 and 0 t to the power 5 all over 4. So we can now perform the integration. So that will be t to the power 6, t to the power 6 over 6 times 4, so over 24, and that will be between the limits of 2 and 0. Now 0 is always friendly to us because there's nothing to calculate there, so our answer is going to be for et squared 2 to the power 6 all over 24, which equals 64 over 24. So we're going to need then for our variance 64 over 24 minus 1.6 squared. So I'll do that on the calculator. And you can see that we have an answer of 0.106 recurring. So if I want to quickly write down the answer to 3 decimal places, it'll be 0.107. So that is the variance of t.